Welcome to the MSJC Internet Authoring Videocast.
In Module 7, you'll be learning about wireless networking. Our objectives for the first session, 7.1, are that you will be learning about the history of wireless networks, learning about Wi-Fi, wireless routers, and wireless mesh networks, understanding how Bluetooth works, learning about wireless broadband networks, examining different kinds of wireless devices, learning about the Internet of Things. Wireless communication technologies have been around almost as long as humans have walked the earth. Beginning with smoke signals, a very limited technology due to the fact that both the sender and the receiver had to be close enough for each to see the signals being sent, to the mid-1800s when Samuel Morse invented the telegraph. Modern wireless communication technologies utilize electromagnetic radiation, or waves, aka radio waves. The early days of radio communications only offered one-way communication and were limited to audio only. The first radio news program was broadcast August 31st, 1920. Radio, both AM and FM, used broadcast technologies, meaning that everyone with the receiver within the range of the signal could listen to the program. It wasn't until the 1970s that personal voice communication devices became wireless, starting with the first generation, 1G, in 1978, which was capable of transmitting voice data only. Second generation, starting around 1990, could transmit voice and small amounts of unformatted data like SMS messages, and later, simple web pages. Third generation, 3G, starting around 2000, transmitted data quickly up to 2 megabits per second, and 3.5G transmitted up to 10 megabits per second. Devices could now stay connected over wider geographical areas, send and receive email, and browse the web. Fourth generation, 4G, started around 2010, transmits data even more quickly, up to 50 megabits per second. Devices have become more like a computer, doing many computer-like tasks on what has become known as a smartphone. Fifth generation, 5G, began implementation in 2015 and touts speeds up to 10 gigabits per second. 5G wireless devices, including smartphones and other mobile devices like a tablet, can now perform most of the tasks that used to require a desktop computer or laptop. When you connect a device, such as a computer, to an internet service provider using a phone line, cable modem, or DSL modem, you're creating a wired connection because the device and the ISP are connected by a cable. A wireless connection occurs when data, such as a file or a person's voice, is transferred to another location without the need for a cable connection. As shown in the wireless device timeline on the previous slide, the first wireless technology was used in 1978 when a voice-only network was started in Chicago and operated on an analog cellular network capable of sending data, but very slowly by today's standards. These analog cellular networks and the cell phones connected to them were called first generation or 1G wireless networks. First generation cell phones were some of the first wireless devices to transfer a person's voice over a telephone network. Eventually, cell phone manufacturers found a way to support and send text data over the same connection. Your cell phone probably lets you send and receive short, usually up to 140 characters, text-only messages, and read them using your phone's display area. This message, called a text message, contains only alphanumeric characters so that devices can send to other devices connected to the same or different types of networks. This kind of data transfer started on second generation or 2G wireless networks, which transferred data slightly faster than 1G networks, but still much slower than the speed that you experience using a wired device. The 2G wireless data transfer rate is adequate for voice conversations and text messages, but it's extremely slow when you're trying to receive formatted information such as a web page. The primary data sent over a 2G network, other than voice conversations, was mostly text messages. With that said, SMS, more commonly called text messaging, is still one of today's most widely used and popular forms of communication methods, with millions of text messages sent each day using wireless devices around the world. As cell phone carriers were converting their old analog cellular networks to digital networks, in other words, moving from first generation to second generation wireless, portable mobile devices were becoming more affordable and popular. Some devices used infrared technology to beam information from one source to another without the use of wired connections. This infrared technology initially eliminated the need for wired connections to share data between devices, but its limitations in range and compatibility problems between devices increased the need for other wireless methods of transferring data, such as Bluetooth. In some parts of the United States and the world, 2G wireless networks still provide voice services and SMS. However, most U.S. and worldwide carriers have upgraded their networks to third-generation 3G wireless networks. 3G offers very fast transfer rates and constant connections. The speed of the 3G network transfer rates lets you use a wireless device to display web pages, play MP3 files, watch videos, make and receive phone calls, send and receive email and text messages, and use global positioning systems that display maps and directions to places around the globe. When mobile devices combine the functionality of a cell phone with an operating system that performs these and other functions, they are usually called smartphones. Each year, changes and enhancements in technology result in an increasing global market for smartphones. The wireless device timeline showed several popular smartphones, all of which let the user perform many operations. When establishing nationwide 3G wireless networks in the United States, carriers originally faced two major obstacles. The first was bandwidth. 3G wireless networks must operate in a spectrum where radio frequencies can carry data. The U.S. government licenses these frequencies for use. The second obstacle was cost. Carriers of 3G wireless signals had to purchase licenses to operate 3G wireless networks, and then they had to build cellular transmitters and radio towers to carry the signals. The challenges of converting from 2G to 3G wireless networks were similar to the challenges of converting from analog to digital cellular networks, which occurred in the 1990s. The carriers had to invest in technology to make the change. Between 2G and 3G networks, many carriers transformed and upgraded their existing networks to create 2.5G wireless networks that delivered faster transfer speeds than the 2G networks. These 2.5G networks allowed devices to send files such as pictures taken with a camera phone to other users and to access the internet. The wireless network that followed 3G wireless, which is called 3.5G wireless network, or mobile broadband, provided very fast network connections. By 2009, 3.5G wireless networks existed in the United States and many other countries. Starting in 2010, many carriers created fourth-generation wireless networks, 4G, which provides very fast network connection speeds and delivers high-quality audio and video to wireless devices. 4G networks make it possible for a wireless device to move between the different wireless networks without losing their signals. The tremendous amount of data that 4G wireless networks can send and receive allows users to perform multiple tasks, such as talking on the phone and browsing a web page simultaneously. Because the devices connected to 4G wireless networks can process many tasks at the same time, this feature is sometimes called simultaneous support. Fifth-generation wireless networks, 5G wireless, became available in 2020. This technology is expected to provide data transfer rates that are much faster than 4G networks, with broader coverage areas and more support for simultaneous users. As the number of wireless internet users increases, more devices will be manufactured to support wireless technology. It is important for consumers to understand that a wireless device is usually manufactured to work only on a single type of network. The networks of the various carriers might operate in different frequencies of the radio spectrum. If you purchase a device for a specific carrier to work on its 3G or 4G or 5G network, you might not be able to use that smartphone if you switch your service to another network carrier because your device might operate on a different frequency than the carrier. Consumers must be careful to select a wireless device that will pick up a signal where they want to use it. Cellular was the first industry to create wireless connections that served large geographical areas. Soon after the creation of cellular networks, engineers developed other ways to create wireless networks with different types of devices. Generally, you can classify wireless networking into three categories: wireless local area networking, or WLANs, wireless personal area networking, or WPANs, and wireless wide area networking, WWAN. It is important to understand each type of network and the technologies used on it so you can determine the correct hardware devices needed. You will investigate the different wireless networks and devices next. A wireless local area network, or WLAN, is a network on which devices use high-frequency radio waves instead of wires or cables to communicate with a base station which is connected to the Internet. A base station, also known as an access point, is a hardware device with one or more antennae which is usually connected to a wired LAN. New computers and all kinds of devices are equipped with Wi-Fi. When most people talk about wireless LANs, they're usually referring to the most common type of wireless network, which is created using the Wi-Fi standard. Wi-Fi, or Wireless Fidelity, is the trademark name of the Wi-Fi Alliance, which you can find at wi-fi.org. The Wi-Fi Alliance is a not-for-profit organization that specifies the interface between wireless devices, certifies interoperability of Wi-Fi products, and promotes Wi-Fi as a standard for wireless LANs. Devices like two Wi-Fi clients, or a Wi-Fi client and a base station, can be used to create a hotspot, which is an area of network coverage that permits communication between wired and wireless networks, so that wireless clients can send and receive data outside of the wireless LAN. Wi-Fi is also used to connect other types of devices such as cameras, home security systems, gaming stations, and IoTs devices, which we'll cover later, to the Internet. Many Wi-Fi devices operate in the 2.4 GHz radio spectrum, which is the same spectrum used by electronics such as cordless phones, garage door openers, and microwave ovens. These electronics can cause interference with your Wi-Fi devices. For instance, you might have problems connecting to your access point when the microwave oven is running, depending on the proximity of the device and the access point to the microwave oven. Because this spectrum is unlicensed, it is free and thereby used by numerous devices. New laptop computers and other wireless devices are manufactured with Wi-Fi compatible hardware installed in them and software that locates a Wi-Fi signal and automatically initiates the connection to the wireless network. Because Wi-Fi certified hardware and devices must meet the requirements of the Wi-Fi Alliance for 802.11 wireless standards, any Wi-Fi certified device can connect to any 802.11 certified access point to send and receive signals, as long as it has permission to do so. A hardware device or a computer running specialized software serves as a central point for wireless clients and provides a connection to the wireless network. These access points already exist in most hotels, airports, convention centers, restaurants, and many other locations. As long as you are using Wi-Fi certified technology, you can connect to the wireless LAN when you're within range of the network and have permission to do so. In most cases, Network connections are possible within 200 to 900 feet of the access point, depending on the network standard, surrounding architecture, and other obstacles to the radio waves. When businesses first started offering Wi-Fi to their customers, many of them charged a fee for its use, and several still do. However, realizing that Wi-Fi is a way to attract and retain customers, some retailers have changed their strategies to offer free use instead of paid or limited use. Many hotels now offer free Wi-Fi and access to a business center that includes printers and other electronic devices that guests can use at no charge. This strategy helps to increase brand loyalty among frequent travelers. Some networks, such as those found in airports and hotels, let you pay a daily fee to use their Wi-Fi network or offer a paid subscription to the service. These services provide secure connections instead of public hotspots. Many businesses provide free Wi-Fi services, but free Wi-Fi hotspots are often not secured, making them less desirable for business communication. Subscribing to a Wi-Fi service will require a payment for use, but it will provide a more reliable and secure connection. Accessing Wi-Fi through a subscription is a good option for protecting the data you're sending over a network. Plus, it eliminates some of the hassles of finding a Wi-Fi provider. The coverage areas of these networks often work well for travelers because they tend to be located in airports, hotels, and conference centers. If you position enough access points within the appropriate range of each other, a wireless LAN can grow to cover an entire office complex or other geographic area. Several U.S. cities, such as Tampa, Florida, have deployed citywide Wi-Fi networks in an effort to make affordable internet connections part of their basic services. These citywide wireless networks are often called Muni Wi-Fi to characterize the wireless network coverage area in terms of a city instead of as a hotspot. Although early attempts at Muni Wi-Fi struggled with financing and device compatibility issues, it has seen a resurgence as it becomes a way to fill in the coverage area gaps when installing wired municipal broadband networks to connect areas that cabled networks cannot reach. A primary example of this exists in Kansas City, Missouri, which was the first U.S. city to install a Google Fiber network. The Google Fiber network uses fiber optic cables throughout the Kansas City metropolitan area to connect residential and business customers and provide them with internet and cable television services at speeds of up to 1 gigabit per second. In areas where fiber optic cable does not exist or cannot be installed, Google used a municipal broadband wireless network to provide coverage, thereby extending the reach of the larger Google Fiber network and ensuring a larger coverage area to its customers. A different type of wireless LAN is a wireless router that you can keep in a pocket or a briefcase and that provides a battery-operated mobile personal hotspot for connecting Wi-Fi devices to the internet. Produced by Novatel and trademarked using the name MiFi, the wireless router obtains its broadband signal through a nationwide cellular service to create a mobile internet connection for Wi-Fi devices, essentially becoming a hotspot for other Wi-Fi devices. The wireless router uses a rechargeable battery that operates for several hours before requiring a charge. The hotspot is password protected and can be used to connect as many as 5 Wi-Fi devices located within 30 feet of the wireless router. When you want to provide other Wi-Fi devices with internet access through a wireless router, you simply enter the password for the device. To create a hotspot, you must first purchase the device and then subscribe to the participating broadband service provider. You can create a hotspot anywhere within the broadband service provider's network. Because a wireless router doesn't use any wires for its power source or signal, it is an excellent option for mobile internet connectivity. This image compares a traditional wired local area network to a wireless LAN. As you can see, the wired LAN connects devices to a switch using cables, whereas the wireless LAN connects devices to a Wi-Fi enabled access point using radio waves. Another type of wireless LAN is a wireless mesh network which is commonly used to extend the reach of Wi-Fi hotspots to an enterprise such as a university campus, hotel, airport terminal, convention center, sports arena, large office building, or apartment complex. Unlike a traditional wireless LAN in which devices connected to the network using a router that is linked to the internet, a wireless mesh network is a series of self-configuring wireless nodes. These nodes are usually access points that speak with each other to relay communication across the network. The advantage of a wireless mesh network is that as new nodes are installed in the vicinity of the network, they automatically configure themselves to work without the use of cables. Similarly, when a node in the mesh network fails, communication is automatically routed around the failed node with little overall loss to the entire network. Perhaps the most important feature of a mesh network is that only one of the nodes needs to be wired to the internet, and then it shares that connection with the other nodes in the network. Perhaps the most important feature of a mesh network is that only one of the nodes needs to be wired to the internet, and then it shares that connection with the other nodes in the network, which automatically determine the best way to transmit the data over the entire network. In other words, communication doesn't always go through the router that is connected to the network like it does in a standard Wi-Fi network. Communication goes through the nodes, which transmit data to the next node and act as an access point in the network. This type of wireless network is generally more expensive to create than Wi-Fi hotspots, but it is more effective and efficient at covering large areas with wireless connections because each node is wirelessly connected to the network, not to the wired router. And each node requires very little power to operate. This image shows an example of wireless mesh networking. Each node might be physically stored on a different floor of an office building or in a different area of an apartment complex to cover the entire geographical area of the structure being connected. Mesh networks are attractive to organizations that are trying to provide wireless coverage to a large geographical area. These networks are also frequently found inside buildings, ports, and airport terminals as a method of controlling information from automated services such as temperature controls, security systems, and fire alarms, all of which use sensors to monitor the operations and status of a large building. In a wireless mesh network, these sensors are linked together through the network and communicate with each other, providing a very reliable and affordable way to monitor the systems in a specific location. The Institute of Electrical and Electronics Engineers, or IEEE, which you can find at IEEE.org, is a standards body which classifies WLANs using different wireless network standards. The most widely used standards are 802.11a, 802.11b, 802.11g, 802.11n, 802.11ac, and 802.11ax. For this reason, some people call a wireless LAN an 802.11 network because of the network standard on which Wi-Fi operates. The range is the physical distance between the access point and the wireless device. The range will vary depending on the physical impediments, such as walls between the access point and the wireless device. In addition, the transfer rate might be reduced when many devices using the same radio frequency are present in close proximity to the access point. Connections is how many devices can simultaneously be connected to the access point. The radio spectrum is the radio frequency the standard uses. Notice that 802.11n supports both 2.4 GHz and 5 GHz, and 802.11ax supports 2.4 GHz, 5 GHz, and 6 GHz. Its support for 6 GHz is what gives it the highest transfer rate of all the 802.11 standards. The data transfer rate is the speed at which the data is transmitted from an access point to a wireless device. The primary difference between these standards is the radio frequency at which they transmit, the transfer rate of data over the network, and the range at which they operate. Wired devices that work in a personal area network, like USB devices, are sometimes called PAN devices, or personal area network devices. You might even hear wireless PAN devices referred to as PAN devices, although technically, if the devices are wireless, they should be referred to as a wireless PAN device or WPAN. Wireless personal area networking refers to the wireless network that connects personal devices to each other, such as a connection between a smartphone and a smartwatch, or between a tablet and a printer. This is in contrast to personal area network or PAN devices, which are connected using cables and technologies like USB. Although others exist, like Zigbee, NFC, and wireless USB, there are two major types of WPAN devices. Infrared, where you can wirelessly beam information from one device to another, with TV and DVR remotes being the most common examples, and Bluetooth, which provides short-range radio links between electronic devices. Although you can use infrared technology to beam information between devices, the most popular method of creating a personal network is by using Bluetooth. Bluetooth devices establish their communication with each other through a process known as pairing. Bluetooth, which was named after a 10th century Danish king, uses radio waves to create short-range connections between compatible computers, handheld devices, smartphones, wireless headsets, printers, and other electronic devices. These devices are manufactured with hardware that enables them to receive Bluetooth radio waves. There are billions of Bluetooth-enabled products on the market. The familiar logo shown in this image identifies a device that uses Bluetooth. Unlike a wireless LAN, Bluetooth does not need an access point for communication. Compatible devices establish their communication with each other through a process called pairing. Because Bluetooth requires minimal power, it is a perfect technology for portable devices. If you want to connect a Bluetooth-enabled device to the Internet, some manufacturers produce Bluetooth access points that function much like their Wi-Fi counterparts in that they connect these devices to a wired network that provides Internet access. Bluetooth isn't really owned by any specific manufacturer or group. According to the official Bluetooth website at Bluetooth.com, the goal of the Bluetooth SIG, or Special Interest Group, is to strengthen the Bluetooth brand by empowering SIG members to collaborate and innovate, creating the preferred wireless technology to connect diverse devices. The group oversees the standards and licensing for all Bluetooth products. This collaborative relationship between developers and manufacturers has resulted in new and creative ways to use the technology in the computer, audio, video, medical, personal health, household industries, as well as many others. This image shows how you might use Bluetooth to create a wireless PAN to connect your electronic devices. When you have visitors to your office, their Bluetooth-enabled devices might also connect to your devices. Because some car models include Bluetooth-enabled phones, you can extend your wireless PAN to include the use of some devices while in your car. Because all Bluetooth-enabled devices are certified and tested to meet current product specifications, they are compatible with each other regardless of the type of device or manufacturer. Using Bluetooth technology, you can synchronize and share data among as many as 8 Bluetooth-enabled devices within the specified range, usually from 30 to 300 feet, at rates of 1 to 3 megabits per second. A collection of devices connected in a personal area network using Bluetooth technology is called a piconet, which can connect 2 to 8 devices at a time. However, all devices connected in a piconet must have identical configurations. In a piconet, one device acts as a master during the connection. You can connect piconets with up to 8 devices to each other, allowing you to share information between the master devices. You can use Bluetooth-enabled devices to transfer files, listen to music playing through a wireless headset, print documents from your office or from another office with a Bluetooth-enabled printer, or use a wireless headset to talk on your smartphone or the integrated phone in your car. Because Bluetooth uses radio waves, the devices must be located within the specified range, but the waves can send data around the corner, down the hall, and from your briefcase without requiring a direct line of sight. Most consumer Bluetooth-enabled devices have a range of about 30 feet and a data transfer rate of approximately 3 megabits per second. Wireless Wide Area Networking, or WWAN, makes it possible to access the Internet from anywhere within the boundaries of the WLAN. As its name implies, a WLAN is a wireless network that provides network coverage to a large geographical area. WLANs provide wireless connections to the Internet using 3G, 4G, or 5G networks created by nationwide cellular phone carriers through radio waves transmitted by communication towers. To access the Internet using a WLAN, you need an integrated or separate mobile broadband card, air card, or USB modem for the device that you want to use and an account with the cellular carrier that operates the network. Once you have a compatible device and an account, you can connect your device to the wireless WAN and access the Internet from any location where the cellular phone carrier has a signal. For this reason, a wireless WAN is an excellent option for mobile connectivity in areas where Wi-Fi service isn't available. Unlike Wi-Fi connectivity, as you travel, your device will remain connected for as long as the device can receive the cellular phone carrier's signal. You may have seen your smartphone connect your cellular carrier's signal using LTE, or long-term evolution, which provides wireless broadband connections at very fast speeds to large geographical areas in the United States and in many other areas of the world. Since 2010, cellular carriers have built nationwide 4G LTE networks. When outside the LTE network's coverage area, 4G devices automatically connect to the carrier's 3G network for their signals. LTE has very fast download speeds of 100 megabits per second and upload speeds of up to 50 megabits per second. In some parts of the world, LTE is being used for residential and commercial broadband service, but in the United States, LTE primarily services mobile devices. Most smartphones and other mobile devices are manufactured with embedded modems to connect to 4G LTE networks. The best way to begin a search for wireless solutions is to begin with an exploration of the network that you will use. Most carriers offer specific products to work on their wireless networks. Some networks, such as those found in airports and hotels, let you pay a daily fee to use the network. Other networks require a monthly fee for using the network. Some local governments have invested in communications infrastructures to create local municipal broadband networks that they manage within their jurisdiction. The Institute for Local Self-Reliance maintains a coverage map for areas in the United States that have broadband municipal networks. The site also documents new networks and posts updates about cities and states that have legislated the right of a community to install a municipal broadband network. The organization advocates for locally controlled citywide broadband networks as a way of providing network service for everyone. You can find their website at muninetworks.org. That's Muni, M-U-N-I, networks.org. Using a Wi-Fi might be a good solution for giving employees some flexibility in where they do their work, either by creating a Wi-Fi network in the main office or by giving them information about where to connect to existing Wi-Fi networks in local businesses. Devices connecting to a wireless LAN through a Wi-Fi or to a wireless mesh network must be within the stated boundary of the wireless LAN. You can use your laptop computer to make a wireless network connection in your office, the conference room, or any other location within the wireless network range. However, when you're waiting for a plane at the airport or sitting in a hotel room in another state or country, you must use another network to connect to the Internet. Although not a new idea, the term Internet of Things was coined in 1999, but was actually in existence almost 2 decades prior to that date. The Internet of Things has expanded exponentially over the past few years due to rapid improvements in technology needed to support it. The Internet of Things, or IoTs, uses machines and other devices that are manufactured with embedded sensors or other mechanisms that collect and transmit data using wireless network connections so that the data can be acted upon by a person or another machine. Examples of IoTs devices would include a smartphone or a smartwatch that reports how many steps that you've taken today, an app that lets you change the temperature of your home before you arrive, medical sensors for continuous glucose monitoring for a diabetic person, or a heartbeat monitor for someone with an irregular heartbeat. How does this data interact and reach you? For example, the dryer in a dorm's laundry room might use an embedded sensor to alert you when your clothes are dry or when a washing machine is available for use. Pressure sensors on a roadway might detect a congested highway and send you an alert with directions for diverting you to a new route. An app on your phone might be linked to a sensor in your home or security system to let you know that the front door was just opened and that the police have been called. All of these situations use wireless communications and different types of sensors to relay data so that you can react to, act on, or monitor the situation. Although technology used in the IoTS devices changes rapidly, it is based on sensors sending data through a network, often using Wi-Fi. Something as basic as a garage door opener might be connected to your home wireless network and use an app that you install on your smartphone to open or close your garage door from anywhere in the world. In this case, the garage door opener is assigned an IP address and is connected to the network so that you can interact with it. Although many things in the IoTS are designed for convenience, there are other uses that could be more profoundly impactful to your life. Medical sensors, for instance, that continuously monitor glucose used by patients with diabetes, or a heart monitor for a person with an irregular heartbeat, can collect data and transmit it wirelessly to the patient's smartphone. When the data indicates a problem, the patient's phone receives a signal and displays an alert. For diabetic patients, an alert that wakes them during the night to let them know that their blood sugar is dangerously low could save their lives. For a patient who is experiencing an irregular heart rhythm, an alert sent to their doctor could result in an ambulance being dispatched so that the patient can be transported to a medical facility. There are other uses for the IoTS devices that extend to a larger scale, such as sensors that monitor traffic and make adjustments to improve traffic conditions, sensors in remote areas that monitor food and water supplies, and embedded chips that can tell you where a shipment is, when it's expected to be delivered, and the ambient temperature of the environment during the shipping. Sensors can also detect oncoming storms with severe lightning, detect areas with impending flash floods, and monitor other severe weather conditions in time for people to seek shelter. As the technology continues to improve so that the sensors needed to monitor and collect data become smaller and require less power output, the IoTS devices will only continue to expand. An estimate by the technology company Cisco predicts that more than 50 billion IoTS devices will be connected to the Internet this year alone, across all different industries and on a global scale. In Session 7.1, we learned about different kinds of wireless networks and the devices that you can use to connect to them. The kind of connection that you make depends on the type of device that you have and the network you're connecting to. Being able to pick up a wireless signal doesn't mean that you can automatically use it to access the Internet, nor does it always mean that you should connect to a wireless signal that you can pick up. In this session, we'll be looking at wireless security concerns, which include service interruptions, interception, hacking, malicious files, theft, and personal harm. Just like in the wired world of networking, ensuring the security of the data sent over a wireless network presents many challenges. Some of the security issues for wired and wireless networks are the same, but many of the challenges in protecting a wireless network are complicated by the fact that the wireless network sends its data through the air using radio signals that are vulnerable to interception. Although there are different kinds of threats to wireless networks, and new threats as hackers get better at figuring out how to manipulate the technology and its signals, there are also security threats to individual wireless devices, the most basic of which is theft of the device itself. When setting up a wireless network for a home or a small business, you can use one or more techniques to secure the network from attacks and other threats. To protect the data that is transmitted over the wireless network, you can enable specific encryption methods. You also need to protect the network from unauthorized access by limiting the devices that can connect to it. You can set the router and individual devices that can connect to that router to protect against unauthorized access. As you learned in Module 6, encryption is the process of coding information so that it is not readable by devices or people who do not have the secret key used to return that information to its original readable state. By default, many wireless networks are unsecured, meaning that any compatible wireless device within the range of the network can connect to it. Unfortunately, Many home and small business networks are never secured and therefore are vulnerable to various kinds of attacks. There are many wireless encryption methods that provide different levels of protection for wireless networks. One of the first methods used to secure wireless networks, Wired Equivalent Privacy, or WEP, is a security protocol for wireless LANs using Wi-Fi that works by encrypting data sent over the network. One of the first methods used to secure wireless networks, Wired Equivalent Privacy, or WEP, is a security protocol for wireless LANs using Wi-Fi that works by encrypting data sent over the network. When WEP is enabled, it encrypts the data sent over the network with a 64-bit or 128-bit key, sometimes also called a passphrase, that is entered by the user. These settings, 64-bit key or 128-bit key, are standards used in the electronic commerce industry to represent the security level of the key. The key works because both the wireless router or access point and the device connecting to the wireless network have the same key and use it to encrypt and decrypt messages. The encryption slows down the network somewhat because of the time it takes to encrypt and decrypt the messages. The level of encryption provided by the key depends on the key's length. A 128-bit key is more secure than a 64-bit key because it's longer and contains more characters. A 64-bit key contains 10 hexadecimal characters, the digits 0 through 9 and the letters A through F. A 128-bit key contains 26 hexadecimal characters. One vulnerability of WEP is that it is possible to decipher a WEP encrypted message. In this image here, we can see the difference between the 64-bit key, which has 10 hexadecimal characters, and the 128-bit key, which has 26 hexadecimal characters. Depending on the hacker's resources, it can take time to decipher an intercepted message encrypted with a 64-bit key, and even longer to decipher an intercepted message encrypted with a 128-bit key. Deciphering a key isn't easy, and it requires a substantial amount of computing power and time. For a person who has these resources, however, it is possible to decipher a WEP encrypted message. For this reason, and because of the actual way that the data is encrypted, many computing experts don't recommend WEP because it provides insufficient security for wireless networks. Another vulnerability of WEP encryption is the fact that the key used to encrypt the data that you're sending is sent over the network before the actual data is encrypted. And this same key is used to encrypt every data packet. This means that you send the key over the network with no protection before the data that you're sending is encrypted. If you change the key frequently, you'll provide some additional security to the network. Although this is a simplified explanation of the problem, it does not support the consensus of most experts that using WEP is better than nothing. But it is not ideal for securing a wireless network. Wi-Fi Protected Access, or WPA, is another wireless network security protocol. It's a standard that was developed by the Wi-Fi Alliance to address some of the inherent weaknesses in WEP. WPA and the subsequent WPA 2.psk version provides stronger encryption than WEP because WPA uses a pre-shared key to encrypt the data, so the key isn't broadcast before the data is encrypted, and individual data packets are encrypted with different keys. This means that a hacker might be able to intercept a data packet, but they won't be able to gain access to the entire message automatically. This will make the content of the complete message difficult to read. WPA can use a 128-bit key or a 256-bit key to encrypt the data. Although WPA provides good protection, one drawback is that all devices in the network need to use WPA. Some older devices will still need to use WEP or another protocol to secure data. Some wireless routers and access points let you use a combination of WEP and WPA when your network makes connections to devices that can't manage WPA. In addition to adding data encryption to a wireless network, You can use other techniques to secure the network by restricting the devices that can access it. Every device that can access the internet has its own network interface card that it uses to connect to the network. Manufacturers of network interface cards add a unique number called a Media Access Control Address, or MAC address, to identify the device. Most routers and access points include software that let you identify the allowable devices using their MAC addresses. By not allowing unknown devices to make connections, MAC address filtering adds another layer of security to the wireless network. Most routers and access points include software that let you identify the allowable devices using their MAC addresses. Identifying devices that you want to connect to the internet is another way to protect a wireless network. If you enable MAC address filtering for a wireless router or access point, then it will only accept connections from the devices with the MAC addresses that you entered. Other wireless devices might detect your wireless network, but they won't be able to connect to it because their MAC addresses are not specified for access. By not allowing unknown devices to make connections, MAC address filtering adds another layer of security to the wireless network. You can identify the MAC address for a device by examining its settings or properties menu. Sometimes the MAC address is printed on the device itself. A MAC address appears as a combination of digits and letters in this format. When a wireless router or access point sends out its signal, it also broadcasts its Service Set Identifier, or SSID, as a way of identifying the network's name. The SSID makes it possible for roaming devices to discover the network and enables you to log in to the correct network. Most manufacturers of wireless routers and access points use the manufacturer name or the word default as the default SSID for a device. When you install a wireless router or access point, you can accept the default name or change it to a name that has up to 32 alphanumeric characters. Manufacturers strongly recommend that you change the default name as part of its initial configuration. All devices that connect to the wireless network must use the correct SSID. SSIDs are case sensitive, so be sure to note the case of the name that you assign to it and use the same case when configuring the devices to connect to it. For public wireless networks, sending out the SSID is necessary because it provides information that a wireless device needs in order to connect to a network. However, for home networks, sending out the SSID is not necessary, especially if you already use a MAC address filtering to identify the devices that you want to connect. In other words, after you configure your own devices to connect to your wireless network, you don't need to broadcast the SSID any longer because you won't need to roam and find the network. Your wireless devices already know the network's name and its settings once they are configured. It is good to remember that disabling the SSID broadcast of a home network makes the network invisible to roaming devices and therefore makes it more difficult for others to detect its signal. By changing the default name of the wireless router or access point, you prevent unknown users from detecting your network. Most people attempting to connect to a random wireless network will look for the manufacturer name or the word default as an SSID. War driving is driving through a neighborhood with a wireless device with the goal of locating houses and businesses that have wireless networks in order to gain access to them. It's a common way for hackers to access unsecured networks. Finding a wireless network that uses default or manufacturer's name as its SSID is a good clue to the hackers that the wireless network's owner didn't take precautions to secure the wireless network. Used alone, and especially with other security precautions, disabling the SSID adds another layer of protection to the network to prevent unknown devices from connecting to it. The term piggybacking is used to describe a person who gains access to and uses a wireless network, sometimes by war driving. You can change the SSID name of your wireless router or access point and disable its signal by logging into the router or access point and changing these settings in the device configuration. When you install a wireless router or access point for the first time, The device is configured with a default username and password that is packaged with the device. The default login is provided so that you can use your computer to access the device's settings and configure it to work as desired. One of the most serious mistakes that home users make when installing a wireless network is failing to change the default login for the device. By skipping this step, you make it possible for anyone who already knows the manufacturer's generic default login information to access your wireless network. If you haven't implemented any other security for the router, such as changing the default SSID or disabling its broadcast, your wireless network is visible and easy to access using the default login. When you install a wireless network, make it a priority to change the default login and password. Be sure to keep your login in a safe place. Remember that after you change it, you won't be able to access the device's configuration page again using the default login. Although you can purchase a wireless router or an access point and start using it right away, it's a good idea to spend some time learning how to configure it properly. You can use this checklist to help you in securing your wireless router. Change the default login and password for the wireless router and access point. Change the default SSID. Be sure you type in the new name in the desired case, as the SSID is case sensitive. Obtain the MAC address of the wireless devices that will connect to the wireless network, and then enter their MAC addresses using the configuration for the wireless router or the device. Enable MAC address filtering on the wireless router or access point. Enable the highest level of security that your wireless devices or wireless router or access point can manage. Be sure to use the most secure key the wireless router or access point offers. If you must use WEP, change the passphrase occasionally. Make sure that all of your wireless devices can connect to the wireless network with the settings that you've implemented. Disable the SSID for your wireless router or access point. And when not using the wireless network for an extended period of time, such as when leaving on vacation, power it off. Because wireless technology makes it possible to work anywhere with a wireless network connection, many people enjoy the freedom that it provides. As you learned in session 7.1, many retailer businesses offer free Wi-Fi service as a way of attracting and retaining customers. Some customers are irritated when a business offers Wi-Fi service, but requires a fee to make connections when other businesses might offer it for free. Fortunately, the technology to install a wireless network is affordable and easy to implement, and many businesses attract and retain customers by offering free Wi-Fi access. Wireless devices of all kinds are subject to many types of attacks, especially when they're used in public places. An over-the-shoulder attack occurs when an unauthorized person uses his or her physical proximity to another person's device to attempt to see login information, passwords, or other sensitive data. People who use wireless devices in public places might not question why another person is standing behind them. They might incorrectly assume that the person is simply standing in line or waiting for a friend. When working in a public place, it's important to be aware of where other people are located in proximity to you and your device, especially if you're using your wireless device to transmit data that you wouldn't want others to see. For this reason, most security experts advise against activities such as online banking, checking email, and online shopping in public places. Not only are these activities visible to over-the-shoulder attacks, they are also subject to being intercepted. In an evil twin attack, also called a cafe latte attack, because the attack often occurs in coffee houses, a hacker gathers information about an access point and then uses that information to set up a device using the real access point signal. This creates a spoofed access point. To other customers, the hacker, it looks like a customer is also using the network. As customers use their devices to detect and connect to the network, they're unaware that they're actually connecting to the hacker's computer. When people use one of the many free public hotspots for wireless internet connections, the data they send over the network usually is not encrypted or secure. This data is subject to hackers using sniffer programs to illegally monitor activity on the wireless network in order to obtain personal information that others might transmit, such as login or credit card number. The hacker uses these connections and a sniffer program to read and store the data that others unwittingly send to his or her computer. When customers engage in online banking or online shopping or log on to a website that has a required password, the hacker easily collects this sensitive data. Depending on what the hacker collects, he or she might later use a stolen credit card number to make online purchases or use login information to access the victim's email account. All of this happens without the victim's knowledge. A third type of attack, called a man-in-the-middle attack, occurs when a third party intercepts transmissions, such as messages between users, logins, and normal connections with servers. For example, suppose device A is sending a transmission to device B over a wireless network. In a man-in-the-middle attack, a third party, the intruder, uses device C to intercept the transmission. In this case, device C might eavesdrop on the transmission to gain information or alter the transmission in some way. In either case, devices A and B are unaware of the intrusion. Preventing man-in-the-middle attacks requires users to ensure that their transmissions are encrypted, that they are communicating with known parties and clients, and that they are aware of anything suspicious in the connection that might make them suspect of an intruder. Just like any other device, a wireless device is vulnerable to certain types of attacks on the data that it stores. For example, Bluetooth-enabled devices are vulnerable to certain kinds of attacks that have no impact on Bluetooth devices that don't have Bluetooth enabled. You'll explore these security issues next. Using public hotspots safely. Avoid online banking, online shopping, and visiting websites that require logins. Don't work in public places if you need to interact with something of value. Establish a connection to a network that provides some kind of login from the access point's owner, even if you have to pay a fee. This connection is more secure than a free hotspot. Opt for a wired Ethernet connection whenever possible when working in a business facility, such as a convention center, sports arena, hotel, or other large building that provides internet access. Many devices are enabled with Bluetooth. The Bluetooth features in these devices allow the user to pair devices, such as a headset, with a smartphone for hands-free use. As you learned in session 7.1, the usual range for a Bluetooth-enabled device is approximately 30 feet, depending on the device. This short range and the fact that you can pair Bluetooth-enabled devices without a password make it possible for someone to access your device without your consent or knowledge. Although many manufacturers have updated their software to prevent some attacks, having a basic understanding of security concerns allows you to secure your device and prevent these and other types of threats. The most common security problems of Bluetooth devices are bluejacking, blue snarfing, and blue bugging. Bluejacking occurs when someone sends an anonymous message to a Bluetooth-enabled device to surprise the owner, express an opinion, or make a social connection. Bluejacking, although alarming to some people, is mostly harmless because the victim's device is not breached. It is only sent a message. The message is usually sent by a bluejacker who takes advantage of the victim's unprotected device or is interested in the victim. Bluejacking is temporary. When the bluejacker's device or your device moves out of range, the messages will stop. Because bluejacking uses a feature of the device designed for legitimate purposes, it does not require special software or equipment. The term bluejacking is coined from the term blue and hijacking. During a bluejack, the device is not actually hijacked, so this combination of terms is a bit misleading. A more serious security problem of Bluetooth-enabled devices, blue snarfing, occurs when a hacker with a special software can detect a Bluetooth-enabled device's signal and gain access to its data without the victim's knowledge. The hacker can access data such as the contact list, connect to the internet, listen in on phone calls, and send email messages from the victim's device. Some hackers wait in crowded areas, such as shopping malls, and set their device to detect Bluetooth signals. If the hacker can make a connection to a vulnerable device, he or she will use it for as long as it's in range to access its data. Since discovering this vulnerability, many manufacturers of Bluetooth-enabled devices have released software updates to prevent the problem, but many owners have not installed them. Newer Bluetooth-enabled devices are not subject to blue snarfing attacks because this vulnerability has been fixed. The most serious security threat to Bluetooth-enabled devices is blue bugging, which occurs when a hacker gains access to the device and its functions without the victim's consent. A blue bugging attack lets the hacker access the data on the device while it's in range. Most manufacturers of Bluetooth devices have released updates to fix the security flaw that makes blue bugging possible. Newer Bluetooth-enabled devices are less vulnerable to these attacks. The two most serious Bluetooth attacks, blue snarfing and blue bugging, can only occur within the range of the Bluetooth-enabled device and on older devices that do not have the necessary software updates installed to protect them. To keep a Bluetooth-enabled device safe from blue jacking or blue snarfing or blue bugging, you can disable the device's Bluetooth feature. This makes its signal invisible to other users, also called undiscoverable mode. Disabling the device's Bluetooth feature prevents others from being able to detect the device, eliminating many types of security issues. A good precaution for users of Bluetooth-enabled devices is to make sure that they use the latest software and to turn the Bluetooth feature off when working in crowded areas. In addition, remember to set a unique PIN number when pairing devices instead of using the default one supplied by the manufacturer. The operating system on most mobile devices is powerful and lets you run apps that check the weather forecasts or create documents in addition to checking email and running a web browser. The predominant operating systems for smartphones are Apple iOS and Android. Smartphones have an operating system that can run programs, also called applications or apps. You download apps for a particular device and operating system by connecting to the online store that sells them, such as iTunes or Google Play. In these stores, apps are organized by categories such as personal fitness, games, travel, and utilities. In each of these stores, you can download apps for your specific device. Apps are developed by companies or amateur programmers and are typically available for free or for a small fee. The app's developer usually must agree to follow the rules stated in the site's acceptable use policy and other requirements before the app is accepted for distribution. iTunes, which includes more than 1 million downloadable apps, has strict requirements for submitting them and only sells an app once the identity of its developer can be proven and it has been confirmed that the app does not violate any coding restrictions of the store. As you might expect, not all apps are accepted for distribution. In some limited cases, an app might contain malware or other security threats that seek to gain access to your device. In one documented case, an app was suspended from the store when it was identified as sending the contacts list and other data from the user's device to the developer's server. In other cases, fake apps containing malware were released to look like well-known popular apps, providing access to the user's device. In one instance, users thought they downloaded a popular and safe app, but instead downloaded an app that contained malware that compromised their devices. Smartphone users should be especially careful when installing apps. When using apps that require login information, such as an app that makes a connection to the user's bank account, you should verify the app's origin by confirming that your bank offers an app. Make sure to follow the instructions on the bank's website to correctly install it. After installing the app, do not set it to save your username or password on the device. This is an important security measure in case your device is stolen or lost. Finally, be cautious about what you install by confirming the source of the download. In general, you can assume a certain level of protection by installing only apps available through the store for your device. Some people unlock and disable the operating system on their devices so that they can run apps from other providers. This practice, called jailbreaking when done on Apple devices or rooting when done on an Android device, is legal but not recommended. If you jailbreak or root a device, you will most likely invalidate your device's warranty. In addition, you might disable some of the security features, making the device more vulnerable to various networks and security problems. Although many people feel that jailbreaking or rooting a device makes it more usable, doing so will most likely compromise the security features provided by the device's operating system. These are some of the basic precautions that each user must take to secure not only the actual device, but also the connections it makes. Almost every wireless device, including smartphones and gaming consoles, has been subject to data breaches in the form of hacking, operating system flaws, or malware. A good way to protect your device is to make sure that the operating system installed on it is always current. As new threats are identified, new software updates are pushed to devices to correct them. If you sync your device frequently and set it to download software updates, you can ensure a certain level of protection. In addition, syncing your device creates a copy of the data that it stores on your computer. In the event of a serious malfunction, theft, or loss, you will be able to use the backup copy of your device to reinstall its data and settings. Most devices include a usage setting that allows you to track your network activity. If you subscribe to a network plan that limits the amount of data transferred each month, you might use this feature to make sure that you do not exceed your maximum data usage limits. Another reason to check the usage statistics on your device is to monitor it for unauthorized usage. For example, if your usage shows several megabytes of data being sent over the network at a time when you were not active, this information could be a clue that a rogue program has been installed and is using your network connection to send information to a third party. If you suspect this type of activity, turn off your device and take it to your network carrier immediately for further inspection. Be sure to lock your device with a password and set it to lock immediately or within a minute or two after use. Locking the device will protect the data on it in the event of loss or theft. Some devices include GPS location features that determine their exact location, which can be used if they're lost or stolen. Some people install apps or enable an additional level of protection to allow them to delete everything on a device when they are certain that they will not recover it. In these cases, if you've been diligently syncing and backing up your data, your loss should be minimal. Another precaution that protects a wireless device is to disable the feature that lets the device automatically connect to Wi-Fi networks when it's within range. This feature is sometimes called Auto Connect and is similar to the discoverable mode for Bluetooth-enabled devices that you heard about earlier in this lecture. By setting your device to prompt you to connect to an in-range network, you prevent it from connecting to the network without your permission. Keep in mind that free Wi-Fi networks are usually unencrypted, so you should prevent your device from automatically connecting to networks, especially when the data sent over those networks might be vulnerable to interception by an unknown party. Try to avoid storing login information and passwords used on your device. For example, if you have a banking app installed, you'll prevent unauthorized use of your account in the event that you lose your device. If you store your passwords on your device, then anyone who has it also has access to your bank account, email, or other private information. When you log into a website using a wireless device, you should deselect the option that instructs it to remember your password. So you must enter your password each time that you log in. By entering the password each time, you'll avoid problems with an unauthorized user gaining access to your login information if your device retains the password for future use. In addition, you should manage the passwords that you use on the device carefully and avoid using the same password for multiple sites. By knowing which passwords you have used, you'll be able to change them easily if you need to. If you use different passwords for your various logins, your logins are protected in case one account becomes vulnerable. And that concludes this lecture. Until next time, stay safe and secure. If you liked this video, please click the like button and leave us a comment down below. I also would appreciate it if you would subscribe to our YouTube channel. Also, click the notification bell so that you'll be notified when new videos are posted.